Okay, let's have a thinking on modular arithmetic. What do we mean when we say A modulo B is equal to R? Well, the common explanation is that when A is divided by B, the remainder is R. This explanation only makes sense when A is a positive integer. For instance, in the equation 5 modulo 3 is equal to 2, we can say that when 5 is divided by 3, the quotient is 1 and the remainder is 2. But when we see the equation negative 5 modulo 3 is equal to 1, can we say that when we divide negative 5 by 3, the remainder is 1? Of course we can't. This leads us to ask, what exactly does the mathematician mean when he says A modulo B is equal to R? This is a matter of definition. When we say A modulo B is equal to R, we mean to say that there exists an integer Q such that A is equal to B times Q plus R, where R is greater than or equal to 0 but less than B. Let me give you another instance where what is said is not necessarily what is meant in mathematics. When we say that a point C divides a line segment AB in a given ratio, we do not necessarily mean that the point C lies in between A and B, which are the endpoints of the line segment it is dividing. It may or may not. So let's have a line segment. Let's have A here, B here. So this is the line segment. So C can be a point here, dividing the line segments in the ratio m is to n. All that the mathematician means when he says C divides AB in the ratio m is to n is this. The distance from C to A, that's AC, divided by the distance from C to B is equal to m over n. This is what is meant by C dividing line segment AB in the ratio m is to n. A point in between A and B can satisfy this equation. A point outside A and B can satisfy this equation. If the point is between A and B, we say it divides the line segment internally. Otherwise, it divides it externally. I will give you another example again. You may have heard that the word poly means many or plenty. When confronted with the statement, the function f of s equals 2 is a polynomial, you are most likely to say it is a false statement. I mean, you have no other option. You don't have a definition, but you have the idea that poly means plenty. It will be miraculous how you say that is a true statement. But it is. Probably if you were told f of s is equal to 2 plus 3x squared plus 5s cubed plus 4 sine x minus 10 cos squared x, you would have said it's a polynomial because it has quite a number of terms. When in fact it is not. And so, definitions I will continue to say, as far as mathematics is concerned, they are not only important, they are crucial. I am currently on tour in the Eastern region, and one of the ideas I'm pushing is this one: definitions are crucial. Others include the fact that mathematics is full of patterns, and mathematicians are constantly looking for patterns. So we are encouraging students to construct relationships between mathematical objects. For example, when we tell you that a triangular number or the nth triangular number is generated from the formula n multiplying n plus 1 divided by 2. And we also tell you that the nth pronic number is generated from n multiplying n plus 1. You must begin to ask yourself, what is the relationship between triangular numbers and pronic numbers? You must not wait for us, because the formula for a pronic number appears in the formula for a triangular number. It is the numerator of the formula for triangular number. So you must begin to do some work on the two and see the relationship. Mathematics is full of these things, and a conscious math student works at these things. So this is one of the ideas that we are pushing. We are also encouraging students to engage in constant practice. I cannot imagine a good math student without this. So if you like the things that we are doing, you can invite us to your school, your academies, to talk and teach about these things, so that together we can help raise mathematical consciousness amongst our students.